This lesson is for FST, Lesson 7.4 on the factor theorem. Really important items in the reading are usually given in a bright yellow box. This particular one here got super blurry when I put it in the notes, so I decided just to simply retype it. So students need to know that this would be a typical yellow box type theorem that would normally be seen from the reading. The factor theorem says if you've got a polynomial p of x, and you know that x minus c, or x minus a number, is one of the factors of that polynomial, then when you plug in just the c value into the polynomial itself, you should get a 0 back. So then there's a lot of implications about that that come in the next yellow box, called the factor solution intercept equivalence theorem, which states that, from page 461, that when you have a polynomial and c ends up being one of the coefficients, then x minus that number is a factor of the polynomial, which also means it's an x-intercept. When you plug that number in, you'll get 0, which means that number is a 0 of the polynomial. And when you divide that polynomial by that factor, the remainder should be 0. So let's put that into practice now with a particular example. So if they ask you to factor p of x equals x to the fourth minus 6x cubed minus 4x squared plus 24x, hopefully students would know to look for a GCF first, and you'd end up with an x on the outside, x cubed minus 6x squared minus 4x plus 24. There wouldn't be anything else that we could factor out, and we haven't talked about any situations where you'd factor where there's 4 terms other than factoring out a GCF. So we'd have to have some other thing that we could do to try to factor this further. So notice their solution involves taking a graph of the polynomial, and you could graph either one, the original or the one that we have already factored out the GCF from, and you'll see that when they graphed it, obviously they would have had to monkey around with the window a little bit. Normally the window goes from negative 10 to 10 and negative 6 to 6. So clearly they widened the graph vertically. And you can see here that it does cross the x-axis 4 times. You can also clearly see it in the table that there are 4 zeros here. So let's write out those zeros just for a moment, just so we can see them as a group. So we're at negative 2, 0, 2, and 6. So now what the factor theorem is saying is that if these are the zeros, we can turn those back into factors by simply saying x minus each one. So if my first 0 is negative 2, x minus negative 2 is going to be one of my factors that it came from. X minus 0 is the next one, x minus 2 is the next, and x minus 6 is the last. Now let's keep in mind here that x minus negative 2, wouldn't we normally write that as x plus 2? And normally x minus 0, isn't that just x? And then we have x minus this 2 and x minus 6. So keep in mind here, if you take each of these and plug them in, you're going to get zeros. Negative 2 plus 2 is 0, 0 is 0, 2 minus 2 is 0, and 6 minus 6 is 0. So now these are the factors of that, and they came directly from the zeros. So if you know the zeros, you can find the factors, and vice versa. If you know the factors, then you can find the zeros. One little comment here for students who have a TI Inspire calculator. If you're stuck on a question and want to check it, you should try it on your graphing calculator. Try defining the function by giving it a name, setting it equal to what it's equal to, and then you can either have it find the factors or the zeros for you. The factor is kind of an easier command. You just say factor and then give the name of the polynomial in parentheses. It'll give you the factors, and then you can probably easily find the zeros from there. So there's further explanation there on page 460 if you want to look at that further. So let's get into some practice questions, like book example number 2. This time they give us a picture, so we wouldn't have had to graph it because they provide it. They tell you to find a third-degree polynomial, and they want you to find an equation for that. Keep in mind that here they do not specify what your equation should look like, other than it's a third-degree polynomial. So hopefully they'll specify in the future if they want your equation in standard form, which for a cubic or a third degree polynomial would be ax cubed plus bx squared plus cx plus d. So we'd be finding a, b, c, and d. Or they might be asking you to find it in just simply factored form, which is something we would probably do first, and then turn it into standard form if needed or if requested. So what we're going to do is just identify where those zeros are and then turn the zeros into factors. And then if we need to, turn the factors into standard form. So let's just identify where those zeros occur. Looks like the zeros are happening at -5, -3, and 2. So then the factors that go with those would be x minus each of those, or x plus or minus the opposite of whatever they have. So x minus a -5 there would be an x plus 5. X minus -3 is going to be x plus 3. And x minus 2 is our last one. So those would be the factors. Then if you needed to list out the polynomial now in standard form, we would do FOIL on the first two and then do distributive property on the second. So I'm just going to go through that real quickly here. So if I do FOIL on the first one, I'm going to get x squared. Outside term and inside term together is going to make 3x plus 5x, which is 8x. And then 5 times 3 is 15. Now when I take that and multiply it by an x and by a -2, first everything gets multiplied by an x, so I get x cubed, 8x squared, and 15x. Then I take everything in the original and multiply it by -2. So now I get -2x squared, -16x, and -30. Now I'm going to look for like terms. There is no other x cubed. X squareds, I've got an 8x and a -2x, so that's 6x squared. Regular x's, I've got 15 and -16, so that's -1x. And looks like the only thing left is the -30. Make sure you set that equal to y, because now you have that in equation form. So here it would have been in factored form, now we've got it in standard form. Unfortunately, we're not done here. I want to show you this graph that the book provides. This graph is illustrating the fact that there are other possibilities for this graph if we don't incorporate the y-intercept. All of these graphs, the blue, green, and red, all cross at the same zeros, but they have different y-intercepts. So the y-intercept needs to be incorporated in our answer. So I'm going to move this out of the way, and I'm going to identify my y-intercept. Looks like the y-intercept is at 0, -60. So every time x is 0, the answer of -60 should be generated. So I'm going to go ahead and plug that number in. 0 cubed plus 6 times 0 squared minus 0 minus 30 should equal the -60. Well, here we're clearly going to get 0 plus 0 minus 0 minus 30, which is -30. So we have a problem. When we plug in a 0, we're only going to get -30, but we're supposed to get -60. So we need to multiply by 2 in order to get that to work out better, because -30 isn't equal to -60. So I'm going to take my polynomial and double everything. Now I'm going to get my new equation, 2x cubed, 12x squared, minus 2x minus 60. Now if I plug in a 0 for x, the first three terms make 0, but the last term is going to make -60, which is what I needed. So now this is my final answer. That's the polynomial in standard form. So I want students to try the next one. Find a third-degree polynomial, this time with the zeros given, not in picture form, but simply listed out. So we're going to take each of the zeros and turn them into factors. So we'd say x minus 1, because remember that the zeros and the factors have to be opposite of each other. Then x minus 3/5, and then x plus 2/3. Now, because this one has fractions and we're not super excited about that, let's go ahead and modify these last two factors to get rid of the fractions. So I'm going to say x minus 1. This one, to get rid of the 5 on the bottom, I'm going to multiply both parts by 5. When I do that, I get 5x, and then 15 divided by 5 gets us back to 3. This one has a 3 on the bottom that I'd like to get rid of, so I'm going to multiply both parts by 3. So I get 3x plus 2. Now that would be a whole lot easier to manage, trying to find the polynomial in standard form. If they only asked us to find the polynomial in factored form, then we'd be finished. and our light blue answer here would be perfectly fine. But if they stay in standard form, then you'd need to go ahead and FOIL and do the distributive property. Give that a try right now and I'll display the answer. Pause the video before you finish. So here's the problem with the first two done in FOIL fashion. Then I did distributive property and I got 15x cubed minus 14x squared minus 7x plus 6. So then there's two more questions for students to practice, number 5 and number 6. Again, give those a try, pause the video, notice the directions. Find it in factored form and then also in standard form. Here you are with your answers. Turn all the zeros into factors first. If you have fractions, get rid of the bottom number by multiplying by that bottom number on both pieces. And then do FOIL first and then the distributive property, making add like terms.